Hi, my name is Talia, and I'm a high school senior who loves teaching others chemistry and math. This YouTube channel is a supplemental resource to anyone who may be having difficulty in their chemistry classes. This week, I'm going to be talking about naming acids and covalent compounds, so if you need help with those topics, keep on watching. Okay, so last week we talked about naming ionic compounds, and this week we are going to be talking about acids and covalent compounds. So we are going to first start with discussing how to name acids. So to give you an overview, acids will always begin with an H. That's how the formula will start. It'll be H and then either a polyatomic ion or another element. So with naming acids, this is kind of a flow chart that I learned that I like to follow, and it kind of just helps make sure you're naming them correctly. So the first question we want to ask ourselves is, does the acid contain oxygen? So if the acid does not contain oxygen, you are going to name it as hydro, and then the element with an ending of ic, and then acid. So for instance, if we had HBr, there's no oxygen there, so this would just be hydrobromic acid because there's bromine in it. Now, if the acid does contain oxygen, there's then another question you would have to ask. So if the acid does contain oxygen, this means that there is a polyatomic attached to the hydrogen. So then we have to look at the ending of the polyatomic ion. So does the polyatomic ion end in ate or ite? So if the polyatomic ends in ate, we do not use hydro in the name, and we just write the polyatomic ion ending in ic and then acid. If it ends in ite, we do the same, but it ends in ous. So that is just like an overview of how you name it. I always remember that to remember which polyatomic ions have which ending, I always remember if you ate something gross, you say ic. So if we had like HNO3, that would be nitric acid. But if we had HNO2, that would be nitrous acid. There are some exceptions to the way you name acids based on the spelling of the element that's included. So with sulfur, if you have anything with sulfur in the acid, you add this extra UR, so it would not be sulfic acid, but it would be sulfuric acid. So it's just like a little bit more of the element name. And then with phosphorus, we would add an OR, so it's phosphoric acid, not phosphic. So if you had H2SO3, it would be pronounced sulfuric acid because this is sulfate. So you know you're going to have an ic, but with sulfur, there's an exception, so it would be sulfuric acid. And a similar thing would occur with phosphorus, except we would use or instead of ur. So now we're going to practice naming these different acids. First, we have HCl. We first ask ourselves the question, is there oxygen? No, so we're going to follow on the no side. So we're going to do hydro and then the element name, ic acid. So this would be hydrochloric acid. So we have the chlor and we have the ic and then the ending acid and the hydro, of course. Next, I already did this example. We have HNO3. This polyatomic ion is nitrate and it ends in an ate and it has oxygen. So we're not going to use hydro and our acid is going to end in ic. So this would be nitric acid. So we have the ending ic with the starting nit and the ending of acid, of course. So this last one, I'm going to change it to H3PO3. So we know we have the polyatomic ion phosphite, but if you remember, it is phosphorus. So we are going to use the exception we have over here. Ite ends in OUS. So I'm going to write this acid as phosphorus acid. So let's decompose this. We have the OUS ending, we have the exception, and we have the beginning of the polyatomic ion. And that is our practice with naming the different acids. Now we're going to practice writing the formulas for acids, and this should be pretty straightforward because we've already done some practice with the formulas for polyatomic ions. So the first step is to write the symbol and the charge for hydrogen. And hydrogen is just H plus. It has a +1 charge because there's one electron in the valence shell. Then we're going to use prefixes to determine the second part of the compound. So like I showed you in the flow chart, if there is no oxygen, we use hydro, ending in ic. There's a polyatomic ion. It depends on the ending, which you can see up here on the flow chart. So then we use the charges, just like any compound, to determine how many hydrogen ions are required, and then we would write the formula. You indicate the number of hydrogens with a subscript, and if you need more than one of a polyatomic ion, maybe if you need to get the least common multiple, you would use parentheses and subscripts, just like with polyatomic ionic compounds. So now let's do some practice with that. Okay, so for our first example, we have periodic acid. So we are going to first write H plus, and we know the polyatomic ion is periodate. So I'm going to write IO4 minus, and then we are now going to balance the charges. We only need one of each. So I'm going to write my final answer as HiO4. Okay, so our next example, we have hydrosulfuric acid. So we have hydrogen, obviously, and there's going to be no oxygen because we have the prefix hydro. So we know we're talking about just sulfur, and sulfur has a -2 charge. So the acid would be written as H2S. Finally, we have hydroiodic acid. So same kind of thing, we have H plus, iodine. We know this is iodine because of the iode, and it's ending in ic, and there's a hydro because there's no oxygen, so we know it's not iodate. If this was just written as iodic acid, that would be HiO3. However, this is hydro, so we're just talking about iodine by itself. Iodine has a -1 charge, so this would just be written as Hi. Okay, so covalent compounds are super straightforward. They are formed between nonmetals, and as we learned when we talked about covalent bonds, they are shared, the electrons in a covalent compound are shared rather than transferred. However, we also learned that with covalent polar compounds, they're shared unequally, and with covalent nonpolar compounds, they're shared equally. So that's just kind of an overview. Now we're going to go into naming covalent compounds. So here are the steps. You first, we have this list of prefixes here. Based on the number of atoms of an element in the compound, you will use these prefixes to write the name of the covalent compound. Like I said, you are going to use a prefix if there is more than one atom to name the first element. However, if you have just one, you are not going to use the prefix mono, and that is only the case for the first element. Then you name the second element using a prefix, and you change the ending to I. However, in this case, if there's one of the second element, you do use the prefix mono. And then there are certain rules with dropping the vowels. So if the vowel at the end of the prefix of the first element is an A or an O, you drop it if the second element starts with that same vowel, A or O, but you don't do that if it starts with an I. So here are the prefixes. We have mono, di, tri, tetra, penta, hexa, hepta, octa, nona, and deca. You are going to want to know these pretty well. A lot of them are like straightforward, and you should be able to memorize them really quickly the more you practice naming covalent compounds. Now we're going to write the formulas for covalent compounds. You first just write the symbol for the first element, and then you write the symbol for the second element, and then you use the prefixes to determine the number of atoms of each element required. The beautiful thing about covalent compounds is you do not need to worry about charges at all. It is based solely on the prefixes. So now we have some, one more thing to talk about with covalent compounds are diatomic elements. These are nonmetals, so they are classified as covalent compounds because they are two atoms of the element by itself. So these elements, when they are not attached to another element, they bond to each other. So if you had, for instance, HF, you would hydrofluoric acid, you would not need two fluorines. However, fluorine by itself does not exist because fluorine is a diatomic element. So if any of these elements are by themselves, they will always have another atom of the element bonded to them. And I like to remember these, and I think most people remember these elements using the mnemonic device Brinkelhoff. So we have Brinkel and then Hoff, or Hoff-Brinkel. Either one works. Okay, so now we're going to do some practice naming and writing the formulas for covalent compounds. So first we have PCl5. So we have one phosphorus, but it's the first element, so we are not going to write mono. And we have 5 chlorines, so we are going to write pentachloride. So this will be written as phosphorus pentachloride. Then we have CS2. So we have carbon, and then there are 2 sulfurs, so carbon disulfide. Okay, so at this example, we have 1 carbon and 1 oxygen. So I'm going to write carbon, and because oxygen is the second element, I can write monoxide. And remember, I did not write it with 2 O's because, like I mentioned with the rule, if the prefix ends in an A or an O, the second element and the second element starts with an A or an O, one of the A's or O's must be dropped. So it would only have 1 O. So next we have boron triiodide, and we are going to write the formulas. Notice how the 2 I's are allowed because they are I's, not A's or O's. So we have boron and iodine, and we know we have 1 boron because there's no prefix and 3 iodines. So the formula will be written as Bi3 because of the tri on the iodine. Finally, we have tetraphosphorus octasulfide. So we know that we have phosphorus and sulfur. So I'm going to write P and S, and due to the prefixes, we are going to have 4 phosphoruses and 8 sulfurs. So I'm going to write P4, S8. And that is how you write the formulas. So now I'm just going to highlight all of these. And that is our practice with covalent compounds and acids. So I hope you enjoyed this video on acids and covalent compounds. Next week, I'm going to be starting a new unit on the mole and mole calculations. So if you need help with those topics, feel free to join me back for those videos. If you would like to schedule tutoring with me, I'm going to put the link to my website in the description box. And as always, if you have any questions or comments, feel free to leave them in the comment section, and I will do my best to respond. I hope you enjoyed the video, and good luck with the rest of your chemistry.